Welcome to Lesson 5 for Chapter 16. We're controlling air pollution in this lesson. Learning objective is you should be able to describe how we have controlled major air pollutants. We've talked about it a little bit, but this is all about it. All right, so just a few success criteria here. You should be able to describe the link between chlorofluorocarbon use and ozone depletion. Describe the effects of ozone depletion. Describe how the problem of ozone depletion has been addressed, because this is one of the few successes that we've had, and then describe how sources of air pollution in economically developed countries differ from those in newly developing countries. So ozone depletion first. So in 1985, it was discovered that a significant thinning of the ozone layer over the Antarctic had occurred during the southern hemisphere spring, so in our fall. The area became known as the ozone hole, and we can see it in this picture right here. And the ozone in the outer layers of the atmosphere shields the Earth from harmful effects of ultraviolet light radiation. So we need it. Without it, that's a huge concern. So chlorofluorocarbons and similar compounds release chlorine atoms, which can lead to the destruction of ozone. And it can take 10 to 20 years for chlorofluorocarbon molecules to get into the stratosphere. So we release them here in the troposphere. It takes a decade or two for them to even get to the stratosphere. And then they remain there and react with the ozone for up to 120 years, depending on what type of chlorofluorocarbon it is. So the Montreal Protocol was an international treaty that was established in 1988. So it's been a while. Initially, limited production of chlorofluorocarbons and halon, which was used in fire extinguishers, at 1988 levels was like the goal. We were just limiting production. But then that wasn't quite enough, so then we further called for the production of CFCs to be reduced by 50% by 2000, but ultimately all production was stopped. It was ratified by Congress in 1988, and the emissions of the chlorofluorocarbons and similar compound emissions dropped dramatically. It appears that the size of ozone may actually be stabilizing and even getting smaller. So this was a huge success for protecting air and our lovely ozone in the stratosphere. So this is a graph of the size. So we started seeing it getting bigger, and remember, it takes a decade or two for everything to even get up there. So now it's started to actually drop off and get smaller. So human releases of pollution into the atmosphere can be controlled. Obviously, like if we're choosing to release the things, we change the things that we're doing. So in the U.S., implementation of the requirements of the Clean Air Act have been the primary means for controlling air pollution. And we've done the reading on the Clean Air Act, hopefully. So the original Clean Air Act in 1970 was amended in 1977 and again in 1990. We should constantly be learning what works, what doesn't, and making adjustments accordingly. Oops. And the EPA has a number of responsibilities under the original Act of 1970 and its amendments. The EPA responsibilities are establishing air quality standards, which we talked about those standards, developing strategies for meeting those standards, and then ensuring that the standards are met. So setting the standards, telling people what they need to do, and then doing the measurements year after year to make sure that we're actually meeting those standards. They also conduct periodic reviews of the 6 criteria air pollutants that are considered harmful to public health and the environment. They're responsible for helping to reduce the emissions of sulfur dioxide and nitrous oxides that cause acid rain. Also reducing air pollutants such as particulate matter, sulfur oxides, nitrogen oxides, which can reduce visibility across larger regional areas, smog. And then ensuring that sources of toxic air pollutants are substantially reduced. And limiting the use of chemicals that damage the stratospheric ozone layer, which again, that has been a success. The implementation of the Clean Air Act and its amendments by the EPA led to the establishment of a series of detailed control requirements to meet the goals of improving air quality. All industries are required to obtain permits to release materials into the air. You basically are paying to pollute. All new and existing sources of air pollutants are subject to national ambient air quality standards. So even if if it was already existing, there's standards of levels that have to be met. And then newly constructed facilities are subject to more stringent control technology and permitting requirements than pre-existing, because those newer buildings, newer facilities have newer technology available to them. There's also hazardous air pollutants that are specifically identified, and then power plants are allowed to sell their sulfur dioxide release permits to other companies. The net result of this program has been a huge reduction in sulfur dioxide emissions. So basically, if a company is like, nah, I got the technology to not pollute, I'm not going to do it, they can make money on that by selling their pollution permits to another company. And a program for a phase-out of ozone-depleting substances like CFCs, halons, carbon tetrachloride, and methylchloroform was established. In 2007, the U.S. Supreme Court ruled that greenhouse gases like CO2 could be considered pollutants and gave the EPA the power to regulate them under the Clean Air Act. Because they are causing a change in the environment and they are doing that in the atmosphere, they're considered air pollutants. In 2011, the EPA established new regulations on the release of mercury and several other toxic substances. So the improvement in air quality since the enactment of the Clean Air Act is a major success story, which we don't get a lot in this class. As a result of the implementing the requirements of the Clean Air Act, a variety of pollution control mechanisms were employed, and air quality has improved significantly over the past few decades. For cars, they were and are the primary source of several important air pollutants like carbon monoxide, VOCs, nitrogen oxides, ozone, and placing controls on the emissions from motor vehicles has also helped with that air quality. For particulate matter, it comes from a lot of different sources like road dust, industrial activities, mining, fires, burning fossil fuels, and there's been a reduction of about 40% for both. The primary pollutants associated with power plants are particulates, sulfur dioxide, and nitrogen oxides. Most particulate emissions have been controlled with filters, and the control of sulfur dioxide requires more fundamental changes to the way electricity is produced, like changing the source instead of coal, using something else. And the EPA approached the problem by setting limits and allowing electric utilities to decide which options are best for them. Nitrogen oxides are produced wherever high temperature combustion occurs with air, and control of the release of nitrogen oxides typically involves processes that are technical and expensive. Emissions of particulates, sulfur dioxide, and nitrogen oxides from power plants have been reduced significantly. So we can see for every single air pollutant identified, there has been a decrease. For some of them, we've kind of like leveled out, but either way, huge decreases from 1980. So air pollution in the developing world, the economically developed world have improved air quality. Less developed countries still have huge air pollution problems, and several studies estimate that the number of deaths worldwide due to air pollution are between 5 and 7 million people per year. So, for example, newly industrialized regions of Eastern Europe, India, and China and the Middle East have huge levels of PM10 pollution. Those are particulate matter from like smoke and things like that. Air pollution in much of the developing world is dominated by poorly regulated industry and the transportation sections of the economy. Economic development begins with the development of industry, which uses cheap labor and basically no environmental regulations to manufacture products inexpensively. And then later comes the regulation. So people are just so eager to have jobs and have development that the risks of environmental contamination is minimal, or the care about that risk. So this is measuring particulate matter pollution over different areas. So most of the U.S. is in the blue, but then when we get into some of the developing countries, they are in the red. All right, that is the end of this lesson. Let me know if you have any questions, and I will see you in the next one.